Welcome. Good morning, good afternoon, and good evening to our audience and to our esteemed panel here at PTC 2021 New Realities. I'm Lynn Smullen, Division Vice President at Verizon and member of the PTC Board of Governors. It is my great honor and pleasure to be the moderator for this insightful panel where we will discuss the present and future of SD-WAN and next generation networks. Joining me today is a most impressive lineup of thought leaders in our industry. We have a rich discussion and a very brief 30-minute window to do so. So let's jump right into introductions. First up is Dr. Nick McKeown. Nick is a professor of electrical engineering and computer science at Stanford. Most notably though, Nick is one of the original founders of the SD-WAN movement that we're all part of today, which is very exciting. He was also founder of several startups, including Abrizio, Nicera, and most recently Barefoot Networks, and he co-founded the Open Networking Foundation, ONF, Open Networking Lab, ON Lab, and P4Org. His current research interests include making networks more programmable and creating tools and platforms for networking teachers and researchers. Welcome, Nick. Next up is Bill Norton, otherwise known as the father of peering. Bill is currently the CEO and co-founder of Syntropy, previously Noya Networks. And Bill has spent his career in the ICT community and is arguably the industry and world leader in peering and interconnect strategy. Bill is also one of the co-founders of Equinix and helped build it to one of the largest $60 billion IBX data center and colo providers in the world. While he was at Equinix, though, Bill really led the industry transformation to collaborate and leverage the power of interconnects and peering. Bill founded and was the first chair of NANOG and regularly consults with governments, universities, and enterprises globally. Welcome, Bill. And rounding this stellar panel out is John Bezaitis. John is the SVP of Engineering and Product at Megaport, where they charged forth really as one of the first true early leaders in the industry, harnessing the power of SD-WAN as a service provider, really transforming the way businesses connect to the cloud, to each other, and leveraging it with speed, agility, and security. John has more than 30 years experience building new technologies and solutions for the networking and security industries, and has also been with many of Silicon Valley's most iconic companies, including Google, Apple, Cisco, and Juniper, just to name a few. Quite an impressive panel. Thank you and welcome, gentlemen. As I noted, it's a pleasure. We have such a diverse set of perspectives here to really help us explore SD-WAN, SD-WAN, network slicing, and what all of this brings to the next generation networking, both today and in the future. As a little bit of background, as we all know, we've all historically looked at networks, or the networks have been looked at as really dumb pipes, primarily because we had lots of flexibility, lack of insight, lack of control, and really the encumbrance from legacy systems. The rollout of next-gen networks utilizing SD-WAN and related technologies is really challenging and changing that view, as well as transforming the experience across the entire ecosystem, from network operator to service provider to hardware and software provider, and ultimately to those most important, our customers. So without further ado, let's get started. So Nick, I'm going to start with you because as one of the original founders of the SD-WAN movement, I'd love to start with your perspective on where we started in this SD-WAN journey, where we are today, and what the future holds for SD-WAN.
Sure, thank you, Lynn. Let me take it, share my screen here. Hopefully you can see that. I'm going to be talking a little bit about sort of an arc, which I think of having taken place over the last 10 years, and then think about where this is going to take us over the next 10 years. So here we are, actually we're in 2021, so you can see I made this a few days ago. But I would think a little bit about where we're going to be going over the next 10 years. But you know, let's face it, we all know that networking and the way that we build networks has changed fundamentally over the last 10 years. And so if we go back 10 or maybe 15 years and think how much networks have changed, I think it'll give us a little bit of a feeling of where they're going to take us over the next 10 years. And I think it's safe to say that over the last 10 years, networks have changed, and the way that we build them have changed more than the previous 20 or 30 years of the internet. And why is that? I'm going to put it to you that it's because we are gradually transforming from a network which is dominated by equipment vendors to one where we think of it as a platform that we program. It's going to take us a while to get there, but I think that we're in that transition. So I think that the first step of that was a change of who is in control. We normally refer to this as SDN. I actually want to put it to you that it's a bit of a bigger trend than that. So back in 2005, networks, as we know, were built from equipment that was closed and proprietary. It was kind of bloated and power hungry. And there was really very little incentive to improve. And we remember that feeling of we were buying mainframes rather than building equipment that would allow us to build our networks better. And the research community referred to this as internet ossification, just a grandiose way of saying things were stuck and no one wanted to really improve them. So networks were hard to manage. It was very hard to change them. They were generally considered to be pretty unreliable, hard to secure. We remember all of the stories of that time. And most importantly, and this is what really prompted the change, it was very, very hard to scale. They just weren't being designed by people that understood how to build big networks. Nowadays, if you look at how different that is, let's look at data centers for a moment, because I think this will actually affect the whole of the networking industry. Now, it's pretty commonplace for the data center providers to build their own networking equipment from white box switches, where they run their own software. So it's homegrown software. They're running on top of merchant silicon that's wrapped in sheet metal. And then it's Linux-based software, open source software that is sort of dominating these systems. We're all aware of this. This is something that we know. But to highlight this change, in that last 15 years or so, we've gone from a time where every data center, every ISP built their networks from off-the-shelf equipment from equipment vendors. Today, all top 10 of the data center companies in the world build their networks from switches that they build themselves. This makes them easier to fix. They can fix problems for themselves. They can add new features when they want to, things that they've always wanted to add, but have never been able to persuade a vendor that it was worth them adding. They can control the traffic to get better use out of their networks, and we see many reports of this. Faster recover from failures because they see them first, they understand them, they're particular to their context. And then intrusion detection, which is something that typically networking equipment has always been very poor at. If you're building a large network, you've got to actually detect and prevent intrusion, and so much easier to do that if you're controlling the software for yourself. But the big deal actually is a much more rapid rate of innovation, much faster innovation, because each is being tailored to its own without having to wait for the 1-year release cycle of the software that comes from the equipment. I categorize this as really as a change of who is controlled. This phase one, a change of who is controlling the network. Now, if there's a phase one, then there has to be a phase two. I wouldn't be saying so otherwise. And I think of that phase two as a change not only in the software that is controlling the network, what we used to call SDN, but now a desire to change the way that packets are processed too. This is something I've been personally very involved with in the last few years. This is a change that is only just beginning right now, but this is where the owners of larger networks are trying to change the way that individual packets are processed. Because let's face it, unless you're controlling the way that packets are processed, you're not really in charge of a network, because all the network really does is take packets from one place to another. And if you're not actually changing the way that they're processed, then you're not really in control of that network. We've seen that this is happening from a movement from fixed function switch chips that are inside switches and routers towards programmable devices. They may be programmed through a language, the modification of C, or like the P4 language, something that I've personally been quite involved with. But generally, programmable switches and smart NICs are just entering the marketplace, allowing the large owner to take control of how packets are processed as well. So we used to say that programmable switches would run slower, consume more power, and cost more. This was the conventional wisdom in 2010. And I'm embarrassed to say this is actually a quote from me, something that I wrote at that time. Turns out it's not true anymore, and we've been able to demonstrate this. So, you know, Barefoot and now part of Intel, but Broadcom and Mellanox and others have all been able to demonstrate there actually is no cost penalty anymore for that programmability, and it's just a rethinking of how these systems are built. So The third change, which I think we tend to forget, we talk about it, but we don't really see their significance, and that's the rise of open source networking software. I mean, back in the early days of the internet, this idea that that you had to demonstrate through open source software your new idea before others would accept it really got supplanted by vendors who wanted to keep things closed and proprietary, and we kind of forgot. But in the meantime, Linux, Apache, Mozilla all came up in the computer system space, meaning that open source software became widely acceptable and we could trust it for important parts of infrastructure. But networking, we kind of forgot about that plan. In the last few years, though, there's been a big rise in the amount of open source that has been used. So it's really re-emerged as a legitimate and trustworthy way to control networks. We've seen some simple examples like Open vSwitch, Sonic from Microsoft being used for data centers, FBOSS, FRR, ONOS. And there's a long list. I would normally insert a graph here showing the sort of the rise in the number of open source projects, but it's very hard to keep track of them now. And it's become legitimate because we're at a point now where something like 99% of all the servers in the world are running Linux, and so they're based on open source software. So why aren't our switches? Why aren't our routers? There's no particular reason not to do that. And that is a trend which is clearly taking place right now. The data centers are already there. The big ISPs are trying to get there too. And I think we'll see this throughout the mobile and 5G infrastructure. So network code has moved from being opaque and closed and is now becoming transparent and open. And so from a security point of view, it's going to be harder to hide bad stuff inside open source software. And there will be more eyes looking at fixing bugs. And really the control plane, the control software is moving away from being differentiating. It's now something that's necessary, but non-differentiating. So it's a ripe candidate for open source. So we'll see much more of that over the next few years. Okay, everything I've said so far, I think it's not particularly new. In fact, most of the people listening to this have said, yeah, okay, I've heard this story before. I think the important thing is, so what happens next? What do these three pillars mean for what will happen to networking in the next few years? And the way I like to characterize it, I think that for the first time, we can think of a platform that we can program. I think this will have profound consequences over the way that we build networks. They are, for the first time, programmable from end to end through switches, NICs, and of course the kernel software at the end, going up into the user space with a language like P4 or other languages that are out there, both in the user space and in the kernel stack. I think we'll see consistent development environments beginning to emerge end to end all across networking. And then also, of course, it's being programmed top to bottom, whether it's that SDN centralized control model or not. Because of open source, it's mean that people are thinking of defining a behavior that went at the top and then compiling downwards towards the forwarding plane. So if it's programmable end to end and top to bottom, it's a platform. It's something that you can program every aspect of it. So we will think of the network as a programmable platform rather than a collection of protocols that are interoperating. I think that idea will seem historic and quaint within 10 years. And we will think of interoperability as happening as a direct consequence of downward compilation of a common set of source programs. So we'll describe the behavior at the top, then we'll partition, compile, and then run across the elements. And the owners of the larger networks will increasingly do that and then tailor it to what they want it to be, whether they're cloud, ISP, or 5G networks. They're going to be programmed and tailored locally to meet the specific needs. And who better to improve the reliability and security of networks than their owners? Because they understand the needs. They're the ones with the customers. They're the ones that understand the problems that they're trying to solve. So I think they will increasingly use very fine-grained per packet measurement. So we'll think of things like ping and trace route, which, let's face it, are the same as they were when I was a student. They haven't changed in 30 years. We will start to introduce much finer grain observation into what networks are doing. And the thing that excites me is that we will start to bring in software engineering techniques to make that software really high quality. We'll use that routinely for things like formal verification of the code itself and on-the-fly checking of the correctness within the network. Different people will do it different ways because they understand how to do this for the networks best of all. So I think that future networks will be programmed by many and hopefully operated by few, because those who own them will have a strong incentive to make them higher quality, more secure, and therefore able to be operated much more efficiently by a smaller crew of operators, which at the end of the day is what they're trying to accomplish. So sort of in summary, I think that this thinking about the network as a platform is going to dominate how we design networks, how we operate networks. And for me as a teacher, it's going to have to affect how we teach the next generation of students. We won't be teaching them about the 7-layer model or anything like that anymore, I don't think. We will be starting to teach them about distributed systems, how you build a distributed system that functions well, that you can program as a platform. So let me leave it at that. And if anyone wants to take me up on any of those points, it'll form a good debate.
John or Bill, any thoughts there? I mean, that's quite a bit of insight, network as a programmable platform. I know, Bill, you have a lot of work you're doing on programmable internet that we'll talk about in a moment, but that's that is definitely game changing. And what's amazing to me is the shift in power and the power that open source drives, and that ability for multiples to build, as you said, multiples to build, to code, to develop networks, but few to run, which is the opposite, right? Quite the opposite of what we have now.
Yeah.
Bill, I would love to get your perspective. How do you see SDN now, programmable internet, and how do you see it moving into the future? And what are some of the things you guys are looking into at Syntropy?
Yeah, well, at Syntropy that we are entering the age of the zero trust internet. We believe that every packet that goes across the internet must be encrypted now, that in the Snowden revelations and all that, we now have to assume that there are cyber criminals, there are multiple nation states, there are, worst of all, advertisers that are catching all of our information, causing asymmetric information out there. So we believe fundamentally that we need to build a more secure internet and one that is traffic optimized. We believe that every packet needs to be encrypted, that there are better paths through intermediaries across the internet that could be brought to bear when there are traffic problems along the public internet. And in fact, we have some data that back up the fact that there are better paths that are not being utilized. There are underutilized network paths across the public internet that if there was some kind of infrastructure, those could be leveraged and even monetized. So, some people call us the Waze of the internet. If you remember Waze, the traffic application.
I live by it, or I used to.
Perfect. Well, if you think about what we're doing, the public internet in the center of this system consists of a whole bunch of organically grown network of networks. We believe every packet needs to be encrypted, and if you go onesie twosie, that works for a while, but when you get up to numbers like 20, 100,000, 20,000, 20 million, it becomes a very sizable problem. So what we've done is we've found a way to create a very thin shim of software that can run on hosts, that can perform one-way latency measurements to all the other nodes in the system. And the content of a single packet includes all the measurements made to that node. And by propagating that information across a group of nodes, not only do they know the public keys of everyone in that group, but they've also measured how long it takes to go direct and how long it takes to go through an intermediary. So all of these edge systems are now endowed with the full mesh of latency between each other. That allows us to do routing autonomously over the top of the public internet. And that is really a powerhouse notion. When you tie that into the idea that, well, if each of these nodes has full information about that group, aren't they in a perfect position to be a validator in the blockchain sense? So that we can use blockchain as a distributed ledger to allow those who share and those who make use of those relays to make sure that there's fairness in the system. That is essentially what we're building. And I think what's amazing about this stuff is, remember the Snowden videos? He talked about how it's a bit of a hurdle to get over for people to get security stuff in place. In fact, many folks consider networking just in general to be kind of a black art. Well, with a system like this, we're building an autonomous organization, so that this software is being put in place on behalf of, I'm going to say it this way, it sounds hammy, okay, but on behalf of humanity. We believe that people deserve and have an inalienable right, in fact, to have a private conversation, not have that traffic being intercepted. And in order to accomplish that, the requirement is that the only two parties that have private keys are the endpoints in the conversation. No third party middleman that can have keys taken over or can be compromised. No, it's the end systems that have to be put in place. So that's basically what we're building. I would argue that no one goes to the market to buy SDN. And I say this having sold SDN for a bunch of years. The number one reason that they go to SDN or it comes up in the first place is security. They have to do something to protect the network. They keep on hearing about all these compromises, credit cards, there's open market for Cisco routers. You can get compromised Cisco routers for, anyway. The point is we need to have an infrastructure in place that allows the edge devices to do the routing and control how their data is communicated. Now, there's an interesting thing that goes on here. Consider GDPR. Nick, this is for you. Consider GDPR as a direction the Europeans are taking in order to say, thou must control the user's data. That is valuable stuff. I believe that now with SDN, we're shifting even a little bit further towards saying, thou must allow users to own and control their own data. Much like I use 1Password to protect my passwords, your personal user information should have that same type of controls. So that when you are deploying your information, you're doing so over an encrypted network, one that is solid and not prone to be penetrated. And at the same time, you're providing better paths through intermediaries of encrypted paths. So what we're doing is essentially turning this whole thing upside down and saying, when you get 5G to the edge and you get massive amounts of network power, we already have a large amount of compute power at the edge. The combination means that these edge devices can in fact route better than the core devices at the ISP. Why? Because they have full visibility and they can route around congestion through these measured paths. I kind of get excited about this because I see a future where we can say on a command line, make NSFNet and have the network spin up automatically with all the locations interconnected. And yes, in fact, run in a Docker, say some ISIS software and recreate all these different models entirely without having to know the black magic, the black art of networking. So that's kind of how I see things.
Wow. Incredible. I tell you, you guys are really breaking new ground there. And I look forward to seeing what that does and how that transforms. We talked about this, the interconnect, right? You helped us create this peering structure and how we needed to leverage interconnects. But now you're taking it to the next step, leveraging security around it, adding intelligence and value there. And more importantly, turning it into you're almost democratizing, right? A great access to good information about a network and making sure everybody gets access to that best path for distribution, like a legacy CDN would do in many ways. But
there's one more interesting aspect to this that you should care a lot about. And that is by having the edge devices decide whether they go direct over the internet or they go through an intermediary, the devices, these edge systems are the ones who are controlling the next hop. So you could buy from a low-cost provider and all of your traffic would automatically discover the better network that could be leveraged and go through that better network. So that would relegate the lower end, lower cost providers to being on-ramps onto the premier high-end, very low latency networks. So to me, there's a possibility for a fundamental shift in the internet wholesale transit market.
Yeah. How do you look at tokens, the whole idea behind tokens? Where do tokens come in here?
Tokens are just a means for settlement, a means to ensure fairness between those who share their bandwidth and those who make use of that better path to the bandwidth. So it's really just a distributed ledger. There's not a lot more than that. We do have a tokenomics paper and there's a staking model and a lot of details for those who want to build a node and relay traffic and earn cryptocurrency for doing so. But that's a little bit beyond the scope of what I think we want to talk about today.
Yeah. No, that's great. Thank you, Bill. Incredible. The work you guys are doing in programmable internet is going to continue to change and evolve how we interconnect, how we operate, the security around it, and I'm really excited to see the future for you guys there. Thank you. John, you are at the center and the heart of SDN and Megaport right now, delivering SDN solutions today. You also published a rather prescient and insightful blog that I'll bring up back in December 2019 that projected that 2020 was going to be a breakout year for multi-cloud and for SDN that you aptly named Multi-Cloudy Skies with a Certain Chance at SDN. Can you share a little bit about what you're seeing, what you're doing at Megaport, and what you see as far as the future for SDN and what that means for enterprises in the future?
Sure. So, one of the things that we tried to look at when we talked about multi-cloud networking was that we saw the advent and the need for enterprises to start looking at multiple clouds and how they run their compute infrastructure. But you can't run compute infrastructure without networking. And being able to have a common network fabric that connects multiple cloud locations to your enterprise, whether it be DC or branch or headquarter premises. So we saw that as something that was an emerging need for enterprise customers. And I think, it still is a need, and I don't think it's an emerging need anymore. So what's next on that path? First of all, it's really service providers that simplify those connections, because the complexity of setting that up on your own is more than most enterprises are willing to put up with. The quality, the skilled labor that you need to build those things on your own is a very rarefied technique, even though you can't hire a Bill or a Nick to go do all this for you, right? So you really have to simplify that, and building API-based approaches to do this is a way of simplifying that. So it becomes a point-and-click solution, whether it be an application developer that is using a Terraform approach to building up those connections, or a web infrastructure to build those connections up. So no longer you're doing CLI to esoteric routing infrastructure. It's all moved up several layers to a layer that most common enterprise managers can deal with. But I don't think that's enough. You have to think about, where do you go next? Now that you've built a programmable substrate, what do you do to that programmable substrate moving up next? And where do enterprise customers need to go to next? And we see a move away from MPLS-based networks, that enterprise customers are moving more to what I call a cloud WAN infrastructure. So taking the same principles that you use to build multi-cloud networks, to start building a multi-location WAN using cloud principles. So that means point and click, be able to build an enterprise substrate with the same way you typically would build your cloud network, which means that you're no longer paying for long-term commitments. You're not thinking about, how do I tee up a circuit from one location to the other. That is provided by the underlying service provider. And it's provided with APIs and user interfaces that enterprise customers can build very complex networks with just a few point and clicks, or a Terraform script, or going through APIs that are built into your underlying application. So that means that an enterprise customer no longer needs to think about the complexities of acquiring and building a network. It's something that they have a service provider that provides the APIs and interfaces to do that for them. The next bit, I think, is the emergence of intent-based networks. And what that means is that you can take all that infrastructure and take the intent that your application needs, whether it be latency and jitter for applications like what we're doing here on this video conference, or you can think about, how do I geofence my traffic so it passes, when we talked about GDPR, that it stays within the geographic boundaries of where I'm allowed to move customer data. Or, you start thinking about cost performance analysis as well. How do I cost optimize my network if I'm willing to give up some performance characteristics? So a lot of what Bill said about, that random amount of network entities that are not being fully utilized, how do I make those available? And you make them available by making customers aware of how they can grab that bandwidth at a cost that makes sense to them. So you go start building APIs for bandwidth brokering on a WAN level scale. That's where we think, enterprises need their networks to grow and to move forward, so that suddenly you're no longer hiring a whole staff to build your network. You're outsourcing that to your service provider, and that's all built with APIs, so you can connect what you need to, when you need to, at a cost that makes sense to the enterprise. Does that make sense?
Oh, right. Yeah, no, I mean, you're right on. That's what enterprises have been saying forever. They don't want to be in the business of designing and running and operating and planning and constantly putting out people to, fix boxes and everything else, and running networks without they want the network to run itself, right? They've said that is, I don't want to have to send in an order form to increase my bandwidth. I want my application to know inherently that at a certain burstability or at a certain seasonality, it naturally, through the intelligence in the network, knows to provision more capacity on a certain route or a certain segment. So yes, that's the dream, I think. So
that's
I have
the dream.
A question.
All we have to do is deliver on the dream now.
We have 10 years, according to Nick's thing, we got 10 years, right? Maybe 2030.
No, and from a time horizon, these, as Nick said, things are moving faster, and we see the way networks are being delivered moving faster as well. The amount of bandwidth that is available on the internet today is just phenomenal, but it's not being utilized. And we have to figure out a way to utilize it the best way possible to make sure it's optimized for the customers that are willing to pay for that optimization. So
and I think, I think, John, this is because we're moving away from a dependency on fixed hardware to moving it we're lifting up that up into software, and now we can move at the speed of software. And to be a bit cliched, it's software's eating the world, but it moves at a much faster pace, particularly when you put it into control of those who need to improve things.
And I think it's like you're looking at like Moore's law for networking, right? And what's happening is that our networks are growing faster than the applications that utilize them. So that's why we have excess capacity, because when we build, at some of my other companies that I worked at, when you came and said, hey, how much networking do you need? Networking was the lowest cost thing when it came from compute, storage, and networking. Networking was the cheapest thing. So I always bought more than I ever needed. And suddenly we have a network that has more capacity in it than most people know how to use. And we just have to unleash that to our customers.
Yeah, well, that's that 50 to 100% oversubscription that naturally is built in for that protection. And so then you start to wonder, how much excess capacity is out there? One of the things that Nick, you brought up, and I think it ties back in, Bill, to the intelligence that you talked about, and John, to some of the work here you talked about when the enterprise wanting the intelligence there. How do we make sure when we build all of that intelligence into these networks through software, that it's doing what we want it to do, right? I saw, Nick, you had a great video that talked about avionics and how we had to build trust. We have trust in those planes that are run completely by software. We need to take and extrapolate that and use that when we build our enterprise class networks for healthcare, for manufacturing, for, name your area.
Yep, there's a long tradition of, there's a long tradition of software engineering that's used in mission critical environments, whether it's the design of semiconductors, where the cost of making a mistake through the electronic design process is, tens or hundreds of millions of dollars, or in avionics, where it would crash a plane and kill a lot of people. So there are environments, but those techniques have almost never been brought to networking. And it's kind of surprising because we depend on the network for everything that we do. And so, that's been because we were building networks out of individual boxes. We had this kind of box mentality, not a software mentality where you're bringing to bear the downward design. So across those layers of abstraction, you can then check and verify that it's doing what you originally intended it to do. So there are well-known techniques that we will bring, which are extremely powerful. And I think that we will see those start to be introduced in the next few years.
There's another challenge, though, Nick. I think when you look at the way that the internet grew from the very beginning, it grew organically, really fueled by financial, controlled a little bit by regulatory issues and what kinds of region that is being serviced, but really it grew organically. And as a result, you have very large paths across the public internet that have highly variable operating models. For some of the software testing I did, my dev team sent me 800 nodes that were hosts that were running VMs within VMs, behind NATs, behind VMs, behind, you get the idea. So the type of variability out there in the internet is way all over the place. And that's one of the things that you have, I think, a difficult time trying to design a control system to deal with such a wide variability underneath the covers.
Yeah, no, I think that in the for quite some time to come, the majority of that software effort will be within autonomous systems, within a single owner who thinks in terms of I'm controlling the peripherals, the switches, routers, gateways, etc., that are under my control. And it will be a long time before they start to then have intelligent conversations across those boundaries, which will be very hard for them to figure out how to do. And I would agree with you, and that will tend to fall back on the kind of the old legacy protocols, which is actually why I agree with you that the more power that you can unleash at the edge in order to bring about that selection of path to the edge point, the more the user will benefit, because it'll take a long time actually for the operators to work together, because why would they want to do that?
Well, they've tried to work together to have security at the edges between their networks, and they've accomplished that between many of the large players. But of course, there's 70,000 ISPs out there, and
yes,
the layers
right.
of security and the routing is
I would
not
agree.
as solid. Yeah.
But then you deal with overlay networks that the provider of the overlay network starts building a contract with the end user, and they look at the underlying components that they're purchasing from the 70,000 ISPs and decide what's the right path that meets that contractual obligation. So, you're right. I think there needs to be fewer players that are delivering those overlay networks with consistent APIs amongst them, so that you can start thinking about not worrying about the underlying network that you're running on top of, because your contract, the contract's being given to you by this middle layer that uses the underlying internet infrastructure to deliver against a contract.
And I think whether that overlay is provided as a commercial service in its own right, or as an edge, as Bill was talking about, in either way, it has the right competitive pressure upon the ISPs, because the better ones will get used more, and that's a good force.
And there's a side effect too that's kind of neat, Nick. When you pull traffic away from a congested path on the public internet and send it through an intermediary instead, it makes the internet better for everybody.
Yep.
Decreasing the pressure along those already known to be congested paths.
This is why I think, Bill, you're democratizing the performance, not just the internet, but the performance, right? So that everybody gets where they can an optimized path by using the platform that you guys are putting together. So.
Cheers.
Gentlemen, well, first off, John, and thank you. Very insightful prediction capabilities you had in 2019. I will tell you that I will be looking to you for Powerball insights as we go into the rest of this year. But look, hey guys, thank you. Nick, Bill, John, you guys have just been such a treat. What an insightful discussion on SDN, and the future is so bright. Indeed, we are just at the beginning of sounds like some incredible impacts as we translate network to a platform, network as software, and leverage software to really propel us in much different areas to support our customers. The next gen network technologies, obviously SDN, SD-WAN, network slicing, they will have tremendous impacts in our industry and our customers globally. On behalf of PTC, though, I want to thank each one of you, because you took time out of your schedule. We can't thank you enough for that, for your insights, for your time, but also for all you do for our industry and all you continue to do to help us innovate and grow. So thank you very much, and I wish you a lovely day or evening.
Thank you. Enjoyed it very much.
Thanks.
Great to see you.
Thanks, guys. Bye now.